Thanks for the privilege and welcome again to our next class as we continue with some examples in logarithms. And in this class, we're going to look at some simple cases that involves problems in logarithms. Let's consider a few of them. Following expressions. Let's simplify the following expressions. 1. We have log 1/16 in base 2. 2. Let's consider simplifying in base 10. 0 0.1, 2, 3, 4, 5, 6, 7. 3. Let's consider simplifying 3. Log of 3 of this. 4. Let's consider simplifying log in base 8, 1 all over 3. 5. Let's consider 5. You see, given that log a of x is equal to 3, let's evaluate I. Let's evaluate I. Log 1 all over a of x, I. Log square root of a of x, I. Log a squared is a squared of x. Then lastly, 6. Let's consider 2x minus 2x minus 2 is equal to 0. Now let's consider, just quickly go through these examples to really see how it will look like. Now, if you can remember from our previous classes, we take a look at some critical cases that will enable us, even without solving, just assuming what the solutions will be. Now, 1, we have been asked to simplify the following. 1 is log in base 2, 1/16. Now, in case we have something like this, if we can remember, when we were dealing with dividing the two terms, we said the quotient, the log of the quotient is equal to the difference of the logs. The log of the quotient is equal to the difference of the log. Example, we had something like this. The log of a of the quotient x over y, we said, is equal to the difference of the log, something like this. So if we have this kind of expression, this is one of our cases, case number 2, I believe. If we have this kind of expression, this we can also simplify in a similar manner. This we can also do in a similar manner. By expressing this thing as a log of 2 of 1 minus the log base 2 of 16. Now this one looks like the second case that we have resolved. if that is true. But also remember, in one of the cases, that I believe case number 3 or 4, I mean case number 4 or 5, we have that the log of 1 to any base, we said, is equal to 0. The log of 1 to any base is equal to 0, where we had something like this. A raised to power 0 is equal to 1. And if we want to write this thing in terms of log, we said this is the log of the base here, A, of the number 1, we said is equal to 0. So if you look at this part, you can see that A is any number, and the log of 1, we said is equal to 0. So automatically this term here tends to 0. That is one of our cases, that's one of the cases that we have considered. So this term here becomes 0. And this one here, we can rewrite it in a way so that it can be easy for us to simplify. How? Remember that this 16, we can write it in terms of 2. And if we want to do that, it's simply 2 raised to power 4. 2 raised to power 4 is 16. Now we choose to do it like this so it will enable us to simplify this other part. And we have been told also that when we have a number in terms of power that is equal to the product of the power and the log. So this further can be written as log 2, 4, 2. Taking this one to the other to multiply the log. And reaching this part, we have also been told from one of the cases that we consider, A raised to power 1, we said it's the same thing as A. A in one place is the same thing as A. And if we want to express this in terms of log, we said this 1 base A of this number A, this is equal to 1. So invariably, we can see that this other part here boils down to 1. If that is true, we have 4 into 1, which is the same thing as negative 4. So if we simplify this expression here, applying those cases that we have considered earlier, the resulting answer is equal to negative 4. Now, if we want to take a look at the second case, where we have case number 2, where we have log in base 10, 0.12345 If we are asked to simplify this, what do we do? Yes, we can do. We can go through this expression. Remember, if we can remember in our previous classes in indices, whenever we have something like this, we said we can also write it in terms of quotient. We can also write this in terms of quotient. This we can write as the log of 10, 1 all over 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is what we have. Now, if it is true, then it is now looking like this other stuff here. So we can also rewrite it in terms of the difference of the logs. And if in doing that, we have this one can further be written as log in base 10 of 1 minus log in base 10 of 1, 2, 3, 4, 5, 6, 7. And as we did also in this other case, the log of 1 to any base is equal to 0. Is equal to 0. So this 10 here automatically boils down to 0. And we have negative. Writing this one also in terms of 10, we're going to have 10 raised to power 7 here. That is what we have. 10 raised to power 7. That is what we have there. Now, from what the similar method, the log of a number, and if the base is still that number, we say that log is equal to 1. So this term here is equal to 1. But before we do that, when we have something raised to power 1, we said we should write it, we can write it in terms of the product of the power and the log. So this we can also write as 7 log 10, 10. So once we do that, you know that this side boils down to 1. And we have this 1. Negative 1, 7 times 1 gives us negative 7. So if we want to simplify this, this is as simple as ABC. We can also go ahead determining that of 3. This one is also a simple case, it's also a trivial case. that we can also just solve through. If we have 3 log in base 3 of 5, if we can remember in the other case, we have said if it is like this, the answer is just simply that stuff. Now this we can also show as if this is this, then let's say this entity that we have is equal to y. Now, if we can remember, this thing is in terms of indices, though the power here is in terms of logarithm, so but it's indices. This number raised to power something is equal to a particular number. So we can write this expression in terms of logarithm. In doing so, we say this power is the logarithm, this power is the logarithm in base this of this number. This is what we have. Now, once you express it in this form, you can now see that this part here is the same thing as this part. So invariably, your y here is equal to 5. So it's just as simple also as ABC. Now the next one I will want us to quickly again look at is number 4. Number 4. And number 4 says, number 4. And number 4 just is simply this: the log of the number 8 in base 8 is equal to negative 1/3. If that is true, in this case, we have also considered simplified similar things like this when we were considering the various cases, where in this case we can see that the base is not known and is expressed in terms of log. So what do? Let's try to write it in terms of indices to see. Now here, this one is the power, this is the number, and this is the base. So what do? This is the base is A, this is the power, which is negative 1/3, is equal to, this is the number. So once you do that, you can see that from here you can just make this A, which is the unknown, the subject of the formula. So what do? In doing so, we are going to multiply the power by -3. Once we multiply the power by -3, this thing will go off. It will be 1 here, and here we will have -3. So here, if we have A, by introducing -3 to the power, we are going to have 8 -3. Now from there is also straightforward, as we can see. This expression that we have here, you can also resimplify it, rewrite it as this, eradicating this negative sign, you have 1/8/3. And your A is therefore 1/8 times 864 times 8 will give us about 512 or so. So this is what we are likely to have. So from this one, you just to determine the value of A, and that is off the job market. The next case that I want us to look at is question number 5. And in question number 5, we said, given that the log of x in base A is equal to 3, that we should evaluate log of x in base 1/8. And this is also pretty simple. Case number I, 5i. This is also straightforward. That is also straightforward. So from here we have that the log of x1/a. That is what we have here. Now, but earlier on we have that this one, the log of xa is equal to 3. So what do? So that maybe it will look like this stuff, so that we can evaluate the value of 3 into that expression. Now from here, let's just say, this entity here, 1/ax, is equal to b. Now, if we have it in this case here now, we can write this thing now. This one is in terms of log. We can write it in terms of indices. If we want to write it in terms of indices, this one is the power, this is the base, and this is the number. So we have the number here. we have the base, which is 1 over a, and this is the power. Now this base here, we can also rewrite this base as a negative 1 and this. Now once you simplify it up to this point, you can introduce this thing into this bracket. This one multiplying this, we are going to have x will be equal to a minus b. X will be equal to a minus b. Now once you have it in this form, we can rewrite this thing again in terms of logarithm. If we want to do that, this is the power here, this is the number, and here is the base. So we say negative b will be equal to the log in base a of that number x. That is what we have. But we already have that from the question. We have that log of x in base a is equal to 3. So this side we can, instead of this expression, because it's looking like this young boy here now, so we can introduce our 3 here. So making b the subject of the formula, you say b therefore equal to negative 3. So from here, we are saying that our a, because we said let this one is equal to b, so this thing here is equal to negative 3. So we say the log of 1 all over a of x is equal to negative 3. That is the answer that we are going to have. Now, in a similar manner, we can also resolve this other part, log of x of the square root of a. We can also do that. In doing so, let's rub off this side of the board so that we can enjoy life with mathematics. We can enjoy life with mathematics. Now, this other one we have the log of the square root of a of x. So this is what we have. So as we did in the other case, we say let that stuff be equal to, say, b. Let that stuff be equal to b. If that is true, then we can rewrite this as we also did in this case. We can rewrite this in terms of indices. If we want to do that, this young man here is the power, this is the base, and this is the number itself. So this is the base, and the base, this is square root of 2. So we say a square root of 2. This is the power, which is b, is equal to the number x. Now, if we introduce this young man in, we are going to have a b over 2 all in this. This is what we have. Now, having gotten this, we can rewrite this thing now in terms of logarithm. And in so doing, we have b over 2 is equal to the logarithm of in base a of x. Now, we have been told from the beginning that log of x of a is equal to 3. So this side here we have 3, and we have b over 2 is equal to 3. So making b the subject, we multiply both sides by 2, and we have b will be equal to 2 into 3, which is equal to 6. Our b is equal to 6. So from here we now say that the log of the square root of a of x is equal to b, which we have as 6. You can see that this is also as simple as ABCD. Now the last case in that same problem is also very similar, so we can still go through it. Using the techniques that we have we've been using. Now lastly, I want us to take a look at this last case where we have it in terms of quadratic equation. But this quadratic equation is only those that have spiritual eyes that will be able to know that what we are having here is we boil down to quadratic equation. Now let's consider this. Now we have 2 raised over 2x minus 2x minus 2 equal to 0. Now when we have something like this, if you look at it, you see that all these things, they have index, though this one is 2x. This one we just have 1x. So, and you see that it's looking like quadratic equation. It's looking like quadratic equation. Now, if that is true, the only case here is we have the powers in terms of x. So let's try to introduce something so that we can eliminate those x that we are having, and in the end we'll resolve them. So we say let p, say maybe unknown, be equal to 2x, so that by the time we substitute, we will see it clearly that it is quadratic equation. Now 2x. So this place here now we have x. The x is in twos. So we now remove this. You can remove this and just have it as 2x, then multiply the 2 later. So in other words, if we have p here, which is 2x, note that we are still having square on top here. While here in this case now we said it is equal to p and 2 all equal to 0. Now reaching this point, the next thing that we do is look for two numbers that when you multiply it will give you this and this, two numbers that when you multiply it will give you negative 2p squared, and those same numbers when you add it will give you negative p. And if you look at it, you will see that is negative 2p, negative 2p, negative 2p, and p. Because when you multiply this, you have negative 2p squared, which is this, and when you add it, you will just have, when you remove this from this, you have just negative p. So these are the two numbers that we need, and when we multiply it will give us this, and when we add them or subtract them, it will give us this. So if that is true, all that we need to write now is p squared. In place of this, we now introduce p minus 2p minus 2, so that this one gives us this entity, minus 2 equals 0, So we now further simplify, taking this one, we have p, when you multiply you get this, then plus when you multiply it to 1, you get this young man. Now the thing we are going to have at the terms we have in the bracket is the same thing that we are going to have here, so p plus 1. Now, but we have 2 and this, so when you put negative 2, when you use this to multiply, you get this, and when you use this to multiply this, you get this, all equal to 0. All equal to 0. So from here, you now take these terms that are outside to form one bracket, and you collect one of these terms that are in the bracket, all equals 0. So the answer here, what we are going to have here, p minus 2 is equal to 0, or p plus 1 is equal to 0. If that is true, you say that p is equal to this one crossing to this other side becomes 2, or you have p is equal to minus 1. But if we can remember from the beginning, we were not having p, we introduced p. So we have to take it back to where we started from. So, but we said p is equal to 2x. So in this case here now, anywhere we see p, we have to substitute that value, which is 2x is equal to 2. Now, lots of indices, you can see that here the base here is 2x. Here the base is also 2, and the power here is 1. So this one and this one goes off the top marker, and we have x will be equal to, therefore, 1 in this case. Or here in this case we have p to be, in place of p we say 2x is equal to negative 1. Anything 1 is says maybe 2 raised to power 0. 2 raised to power 0 is 1 with the negative sign. But in this case we can't just go through it the way we have it here, because we have a negative sign in front of the 2 in this case. So we say here in this case, x does not exist in this case. But we have that, in the first case we have that x is equal to 1. So you can now see that from this kind of expression, we were able to resolve it to quadratic equation, and that is of the job market. So with all these that you have in the various cases that we have at our disposal, you will be able to go through any mathematical jogging as the case may be. I wish us success as we continue studying with this series and put more attention to what we have been doing. And I believe anything elementary mathematics will be a thing of the past for us. Before I end, please don't forget to subscribe. Click on the subscription button. It won't cost you anything as we move forward to other topics. Maybe our next topic we're going to go with simple inequalities. Thank you and God bless.